Good morning, my dear students. Welcome back to the virtual class of Milestone College. This is AFM Yusuf, Assistant Professor, Department of Chemistry, Milestone College. Dear students, today I am going to teach you the creative question of metallic part of chapter 10. This is a very important creative question. There is 8.4% P metal in the earth crust and 5% Q metal in the earth crust, and R metal exists in the metallic alloy in 90% in amount. So the question is, explain the electrolytic purification of process of R metal given in the stem, and the extraction methods of metal P and Q are different. Analyze it. Dear students, first you have to know the percentage of ingredient of earth crust. Look at the whiteboard. I am showing you a pie chart of different ingredients of earth crust. The prime amount of earth crust is actually, prime ingredient of earth crust is actually oxygen. It is 46%, then potassium 3%, calcium 4%, iron 5%, aluminum 8.4%, silicon 27%, magnesium 2%, others 2%, and sodium 3%. In our question it is given 8.4%, so it is understood, it can be understood easily. 8%, I mean P indicates aluminum metal and Q in the earth crust, Q contains 5%, so 5% is actually iron. I mean Q indicates iron, and metallic alloy, 90% exists in the metal alloy. Dear students, first you have to know what is alloy or metal alloy. If two or more different metals, molten metals, are mixed together in different ratio, then the obtained mixture is actually known as alloy or metal alloy. Metal alloys are actually more sustainable. Metal alloys are more sustainable than metal. That's why metallic alloy is more preferable for making different articles, for using articles like bronze. My dear students, you have to memorize the percent amount of metallic alloy, percent amount of different metals present in metallic alloy. Now in our question it is given 90% exist in the metal alloy. Actually bronze contains copper and tin, I mean stannous. So R actually indicates bronze, and bronze contains 90% copper and 10% stannous, I mean 10% tin. Okay, so my question on C is the purification of impure copper. Actually, dear students, you have to memorize this pie chart, chart of ingredient of earth crust. Then you have to also memorize the percent amount of different alloys or metal alloy. However, it now seen on question, I have to refine the impure copper through the electrolysis process. For this purpose, the impure copper is made anode and pure copper strip or pure copper is made cathode, and both of the anode and cathode are dipped in the aqueous solution of copper sulfate. Here copper sulfate is used as electrolytic substance, and then anode and cathode are connected with the battery. Anode is connected with the positive pole of battery and cathode is connected with the negative pole of battery. After passing electricity in the anode, copper releases 2 electrons to form copper 2 plus ion in the solution. So, anode reaction, copper releases 2 electrons to form copper 2 plus ion, and then this copper 2 plus ion goes to the cathode and accepts 2 electrons to form copper metal on the surface of cathode. This is actually cathode reaction, and the deposited copper is actually 99.99% pure copper. My dear students, by this process impure copper is refined to get 99.99% pure copper. Okay, dear students, look at the question on D. The extraction methods of P and Q metals are different. Analyze it. I mean, P means aluminum and Q means iron. I mean, the extraction metal is actually aluminum is extracted by electrolysis process and iron is extracted by carbon reduction process. Now my question, why the methods are different? This is the question. To understand this question, you have to know the reactivity series of metal. Look at the whiteboard. I am showing you the reactivity series of metal. Dear students, look at the whiteboard. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper and silver. This is the reactivity series. Actually, the highly reactive metal, I mean the metal which has more tendency to release electron, is more reactive metal. Here actually potassium has the highest tendency to release electron. That's why potassium is placed at the topmost position of the series according to the tendency of releasing of electron from their last shell. The metals are placed one by one to get a series which is actually known as reactivity series. Aluminum is a high reactive metal because aluminum exits at the top part of the reactivity series. So, as aluminum is a high reactive metal, it does not find in the nature as free metal. it is found in the nature as compound. It is found in the nature as bauxite. You know that bauxite is actually the ore of aluminum. The formula of bauxite is aluminum oxide dot 2 molecules of water. So, through the different steps, the bauxite ore is refined, then pure aluminum oxide is obtained. This aluminum oxide is actually done electrolyzed. Though this actually I would like to show you a simple figure of electrolysis of aluminum oxide, but this is actually not the figure of aluminum metal extraction. Here actually I don't want to show you actually the aluminum metal. I would like to just say you the extraction of aluminum metal just shortly. Aluminum oxide is taken a steel tank, and a layer of graphite is given in the inner side of the steel tank, which is actually used as cathode, and 3 graphite rods are inserted into the aluminum metal extraction, which is actually known as anode. Those are actually anode, and the graphite layer is used as cathode. And after passing electricity, aluminum oxide dissociates to produce aluminum metal and oxide ion. Already I have told you aluminum is highly reactive metal. Highly reactive metals means aluminum has high tendency to release electron to form aluminum 3 plus ion. So this aluminum 3 plus ion is very stable. That's why it is very tough to bound aluminum 3 plus ion to accept 3 electrons to form aluminum metal. That's why highly reactive reducing agent is used here to reduce the aluminum 3 plus ion. And electrolysis process is actually highly reduction process, very powerful reduction process. And in this process, the cathode aluminum 3 plus ion goes to the cathode and accepts 3 electrons to form aluminum metal. In the all electrolysis process, the highest refined metal is obtained, as well as aluminum. The obtained aluminum metal is pure aluminum metal. Now come to the another point. The Q metal is actually iron, and iron is extracted by carbon reduction process. Actually, in this case, Fe3 plus of ferric ion of ferric oxide is reduced by carbon. Here actually at high temperature, at the lower part of the blast furnace, carbon is burned. Then this carbon is oxidized by atmospheric oxygen, the supplied atmospheric oxygen, to produce carbon monoxide. Then ferric oxide is reduced by carbon monoxide to produce iron metal and carbon dioxide. Here carbon is actually medium reactive reducing agent, as iron is a less reactive metal. So the position of iron is actually lower part of the reactivity series. That's why ferric ion is less stable than the ions of higher reactive metals. So ferric ion can be reduced by medium reactive reducing agent. Carbon is a medium reactive reducing agent. Here actually carbon converts into carbon monoxide, already I have told you. Then carbon monoxide reduces ferric oxide to produce iron and carbon dioxide. Dear students, I would like to show you the reduction process here. The oxidation number of iron is +3, and here this is free iron, that's why the oxidation number is 0, and Fe3 plus, ferric Fe3 plus accepts 3 electron to form iron metal, and all of you know that metal electron accepting process is a reduction process. That's all about the reason of different extraction methods of aluminum and iron. That's all, my dear students. No more today, and I will discuss about the non-metallic part of this chapter in my upcoming lecture. Goodbye.